Alright, welcome. In this video, I'm going to be working Algebra 2 Homework 10.2, and we're going to be graphing a bunch of rational functions. And so we're going to start with some functions, and we're going to find the domain and range of each of them. A is f of x equals 2 over x plus 3. Okay, to start with the domain, what we're going to do is grab the denominator of the fraction, whatever fraction we're working with, and we're going to be working with a fraction because we're talking about rational functions right now. Domain, we're going to just grab the denominator and we're going to say that is not going to be able to equal 0. It's not going to really require any further solving, so I'm just going to, okay, so x is not equal to 0. That's my domain. All x that are not zeros are suitable to plug in for x. That's basically what we're saying there. And then for range, okay, 2 over x, that's the type of thing that's not going to be able to equal 0 because 2 is not 0, and the only way a fraction can equal 0 is if we have 0 on top and something non-zero on bottom. So I'm going to say, all right, 2 over x is the type of object that can't equal 0, and that's what f of x is. Oh, no, it's not. I need to add 3 to that, so 3 plus 2 over x, let me just zoom out a little bit. That can't equal 3 plus 0, and so that would be like saying y can't equal 3. So that's going to be my range. The next one is g of x equals 4 over x plus 5. This one, do the same thing. Start with the domain. Say x plus 5 is not going to be able to equal 0. If I subtract from 5 from both sides, that will be x is not equal to negative 5. Okay, if you can just look at that fraction and say, okay, it's going to be all x's except for negative 5, good for you, great. Just write that down, move on. I'm just showing you how to solve for it if you don't immediately see. And there will be some of these later on where you're not going to be able to just immediately see what kind of x would make the denominator equal 0. You have to put in a little extra work. Okay, the range, okay, we've just got a fraction. Okay, 4 over something that's, well, really 4 over anything is not going to be able to equal 0. In our case, we're interested in 4 over x plus 5. Okay, that's y. So it's just y is not equal to 0 for the range. Right, the next one is h of x equals 6 minus 7 over x plus 8, which is really kind of, I guess, like both of these put together, the first two. So I'm going to, for the domain, do the same thing I've been doing. X plus 8 is not equal to 0. So that means x is not equal to, wait, no, that was supposed to be a minus. Whoops. So it's an x minus 8. That would want to become a minus 8 as well. And that means that x is not equal to positive 8. Okay, and then the range will be, okay, we'll start with the fact that that fraction 7 over x minus 8, that can't equal 0. Not possible. Okay, so if I added 6 to it, or I made it negative, maybe I should say negative 7 over x plus 8 is not equal to 0, right? Still for the same reasons. That fraction can't equal 0, so the negative version of it couldn't equal 0 either. So 6 minus 7 over x minus 8 is going to not equal 6 plus 0, or 6 minus 0, it might be more accurate to say. Okay, so it can't equal 6 minus 0, and that's like saying y can't equal 6. D is 1 over x squared minus 3x plus 2. So this one's a little different. I've got a quadratic in the denominator, but I'm going to approach this the exact same way. For the domain, I'm going to be thinking, okay, the denominator can't equal 0. Okay, so I'll say that means that x squared minus 3x plus 2 cannot equal 0. Okay, so this is the type of thing I could factor it. I could think of two numbers that multiplied to positive 2 while adding to negative 3. That would be negative 2 and negative 1. And you could either just look at this as, you know, like solving an equation, and it's like, okay, it's not equal to that, and it does work the same way. But you could also say, okay, the product of two things is going to not equal 0 anytime both of them are not 0. Okay, so I just need both of these things to not equal 0, and that'll happen as long as x is neither 2 nor 1. Let's say x is not equal to 2 and x is not equal to 1. It's really not or there, it's nor. But we're not really worried about that stuff in Algebra 2. I'm just going to say x not equal to 2, x not equal to 1. And for the range, I probably didn't need any more room here. Okay, this is just a fraction, okay, with 1 on top and something not 0 on bottom, if it's defined. But even if it was, okay, that's not going to equal 0. 1 over anything is not equal to 0, so I'm just going to say y is not equal to 0. And I feel like I could say the same thing about this next one. It's just a fraction with 2 on top and, variables on bottom. I don't have anything added on the outside. So I'm just going to start off by saying the range of this thing is y is not going to be equal to 0 for the exact same reason as the last one. Okay, then the domain of this one, I might have to do a little bit more work, but hopefully you can see where this is going. Okay, we're going to grab the denominator, set it not equal to 0, and something like this, a third degree polynomial with 4 terms and kind of parallelism from the first 2 terms to the second 2 terms, that's going to be group and factor. Okay, so I set those not equal to 0. I say, what can I factor out of the first 2? That's an x squared. From the second 2, I can factor out that -4. I'm going to keep going with this factoring by factoring out that x plus 3. If you just could remember that x squared minus 4 is equal to 0 at 2 or -2, you wouldn't really need to keep factoring, but I feel like it would be a good time for me to remind you that it can be factored into x plus 2 times x minus 2. Okay, and then I think it's most obvious that, okay, this denominator will not equal 0 as long as x is not equal to 2 or -2 or -3. The last one I've got for you, this one's a little tricky. So, let me think about this. I know what you're supposed to do. Okay, I didn't know what I was getting at here. I had to think about it myself. The domain, that's just going to work the same as the rest of them. Grab the denominator, make sure that's not 0. But the range, this one's tricky because I haven't trained you on this. It's like, what do I do with this type of fraction? Okay, the numerator can equal 0. The numerator could equal 0 if x was -1, and the denominator would not equal 0. Okay, so this fraction is able to equal 0. I'm gonna tell you, but I want you, before I tell you, to just think about x plus 1 and x plus 2. Those are different numbers. And if you take two numbers that aren't the same number and you divide them by each other, there's one thing they can't equal, right? You can't have 1, because the way that we get 1 by dividing two numbers is dividing a number by itself. And x plus 1, x plus 2, they can't be the same thing. So on a number sense level, I'm asking you to recognize that the range is y is not equal to 1. I will have a much better way for you to determine that in the next lesson. Okay, a much more believable technique that you don't have to rely on thinking about numbers or things that are not all that algebraic. This will be a very algebraic technique. We'll just actually do long division on that and see that we can rewrite it in a form that would be more recognizable. All right, so now number 2 is asking for the equations of any vertical or horizontal asymptotes to the graph of each function. All right. So what's going to happen, a couple of these I'm not, especially D. I'm not sure what you're supposed to know about D, but who knows, we'll get there eventually. Okay, I think I'm going to just remind you what causes the vertical and horizontal asymptotes. So the vertical asymptote and horizontal asymptote discussion is very related to the domain range discussion. I'm going to even use the same colors. So vertical asymptote is caused by 0 in the denominator, just like those values that we're removing from our domain. And horizontal asymptote is really caused by that same thing that's impacting our range, the fact that 1 over u can't equal 0, kind of regardless of what u is. And I'm still thinking about D. I'm not sure what's going to happen there, but let's just get on with these first three. These will be straightforward enough. First one's f of x equals 1 minus 2 over x. And we're going to say, all right, a vertical asymptote that'll be x equals 0. Okay, it's an x value that causes division by 0. And the horizontal asymptote will be at y equals 1. because 2 over x, that can't equal 0, so my graph is going to be getting closer and closer to y equals 1 the bigger x gets, right? Because 2 over x can't equal 0, but it can get really close to 0, so I'm getting closer to subtracting 1 minus 0 the bigger x gets as x approaches positive infinity, and kind of the same story for negative infinity. I'll just be 1 plus a really small number, because 2 over a huge negative number, that would be a really small negative number, and be subtracting a negative, which would be adding. All right, so horizontal asymptote, that's going to be y equals 1. All right, with B, the vertical asymptote is going to be x equals 4. It's whatever x value would cause the division by 0, 0 in the denominator. And horizontal asymptote, that's going to be y equals 0. Because 3 over x minus 4 can't ever equal 0, and so, but as x gets really big, 3 over x minus 4 could get really close to 0. You know, if x was like 1,000 or something, 3 over 996, that would be a really small number. And you could make it even smaller by making x even larger. And so y equals 0 is going to be the horizontal asymptote there. C is, I guess, a little more interesting. So it's 5 minus 6 over 2x plus 7. And to get the vertical asymptote, I'm going to go over there to the denominator and say it's okay, it's whatever x value is causing 0 in the denominator. So 2x plus 7 equals 0, where 2x equals negative 7 and x equals negative 7 halves. And then the horizontal asymptote, that's going to be y equals 5. You could also look at it as, you know, negative 6 over 2x plus 7. That graph would have a horizontal asymptote of y equals 0. We know that. And then I'm just adding 5, so that's going to shift the whole graph up by 5. Either way, horizontal asymptote, y equals 5. All right, with this one, man, I'm not sure what I was going for here. The vertical asymptotes, those will be easy enough to find. Right? Just like before, we're going to take the x values that cause the denominator to equal 0. That's going to be x equaling 5 and also x equaling negative 4. The horizontal asymptote, I think I'm going to just tell you that this is y equals 0, and also tell you that kind of the reason behind that is a little beyond the scope of what we're doing here. I've been saying horizontal asymptote is caused by, 1 over a number not equaling 0, and that is partially true, but there's also more to it than that. When we go and study more complicated rational functions like this one right here. And so I think I'm going to probably just leave it there, but also I might, bring in a Desmos window. So, see how, also because the numerator can equal 0, we do have that x-intercept right here. Let's see, no, you can't see my cursor, that's odd. Okay, well, but, right there at x equals 3, we're seeing a crossing of the x-axis. So this is the first time you've seen a horizontal asymptote can be crossed. Okay, you see those vertical asymptotes at x equals negative 4, x equals 5, those are pretty plain to see. But I would also just, zoom out and show you that the rest of this graph, the bigger x gets, the closer it's getting to the x-axis. And the same thing over here as x approaches negative infinity. Okay, let me scroll for a second. We're seeing the same thing over there. Okay, so y equals 0 is going to be a horizontal asymptote. If we go back to our definition in the notebook, it said it's a line that we're getting closer and closer to as x or y or both go towards infinity. And this is x going towards infinity right here. And I'm allowed to say, that was good, but this is beyond the scope of what we're doing right now, and this is not something you would expect to see on a quiz or a test or anything like that. So let's move on. All right, with g of x equals 1 over x to the 3 minus 2x to the 2 plus 3x minus 6. Okay, with the vertical asymptote, we already kind of did this type of situation once. We're interested in where the denominator is going to equal 0. So that'll be x to the 3 minus 2x to the 2 plus 3x minus 6 equaling 0. Okay, and we're going to group and factor. So I'm going to factor out an x squared out of the first 2 and a 3 out of the second 2. Factor out the x minus 2. And then, okay, I can't factor that x squared plus 3, so I'm going to solve each of these individually. X minus 2 would equal 0, where x equaled 2. or x squared plus 3 would equal 0, where x squared equaled negative 3 and x was equal to plus or minus, wait a second, the square root of negative 3, that's not a real number. Okay, we know we can write that as an imaginary number, but we're not interested in vertical asymptotes that happen in imaginary numbers because we don't plot that on our, our graphs. We just have an x-axis and a y-axis, and those are both real number lines. So I'm going to say my vertical asymptote is just x equals 2. And the horizontal asymptote, that's going to be y equals 0 because I've just got a fraction and it's not going to be able to equal 0. But it's also equal to 0 because the bigger x gets, positive or negative, the bigger the denominator gets. I'm dividing by a larger and larger number while the numerator is staying constant. And my quotient, the result, g of x, that's getting closer to 0. That's another reason why y equals 0 is a horizontal asymptote for this function. And then h of x is another function, kind of like on the last problem, where this is, really we're going to talk about this more next time. But, okay, vertical asymptote, we should be able to do that. That's where x minus 3 equals 0, that's x equals 3. Okay, that'll be the equation of my vertical asymptote. And the horizontal asymptote, okay, guess kind of because it's been the value that's been excluded from the range for the most part outside of that weird one, d. We're going to say y equals 1, kind of like f on number 1. X minus 2 over x minus 3, that can't equal 1 because x minus 2 and x minus 3 are distinctly different numbers, right? If you take a fixed x and you subtract 2 and you subtract 3, you're going to get two numbers that are off by 1. Okay, and you divide them, you can get all sorts of different stuff. But overall, that can't equal 1, and so that's why I'm going to say y equals 1 is a horizontal asymptote to that. Number 3 asks for us to find the x-intercept on the graph of each function. So that's really just going to amount to us setting the thing equal to 0 and solving. So for f of x equals 1 over 2x, and I'm going to just set all of these equal to 0 and try to solve, and if I arrive at a contradiction, I arrive at a contradiction. I think that's what's going to happen here, and I see another one where that's going to happen. Alright, anyway, so I'm just going to say x-intercept, that's where y equals 0, so f of x equals 0, so 0 equals 1 over 2x. I would multiply both sides by 2x to get rid of that denominator, and I'd get 0 times 2x equals 1. Okay, but I know that 0 times anything is equal to 0, so this equation has no solution. You could also just say that 0 equals 1, no solution, no x-intercept. And with these, if there's no x-intercept, it's most likely, especially today, on these, that the reason that we don't have an x-intercept is because we're on a vertical asymptote, and that would make sense. It causes the denominator to equal 0. For g of x equals 3 plus 12 over x, I have more hope for this one. 0 equaling 3 plus 12 over x, because an x-intercept, in fact, I'm going to just write it once and leave it there. That's going to be where y equals 0. So I set y equals 0 and solve for x, like we've done many times in this class. So I'm going to subtract 3 from both sides, equals 12 over x. And it might be that this is an equation you can solve with your eyes. If so, go ahead and say what x equals. If not, multiply both sides by x, negative 3x equals 12. Divide both sides by negative 3, and x equals 12 divided by negative 3, which would be negative 4. Okay, so my intercept will be negative 4, or we could write it, maybe I'll write it as a coordinate pair, negative 4 and 0. C is h of x equals 1 minus 2 over x plus 5, and so I think this one will work out pretty similarly to the previous one. I'm going to add, maybe I'll add the fraction to the other side. Add 2 over x plus 5 to both sides. That's something you can do as long as you add it to both sides. So 2 over x plus 5 equals 1. And then I'm going to multiply both sides by x plus 5. So 2 equals 1 times x plus 5. Well, if I multiply something by 1, that's not going to do anything to it. So 2 equals x plus 5. I'll subtract 5 from both sides, and I'll get x equaling negative 3. And so my x-intercept will be x equals negative 3 and y equals 0. Now, I suppose it would be possible for you to get an extraneous solution when solving this type of equation. So I guess, you should be double checking and making sure you're not getting an x-intercept that corresponds to a vertical asymptote, but I'd have to really think hard to come up with a problem like that, and I'll just tell you right now, I didn't think that hard. So The next one's x plus 2, oops, f of x equals x plus 2 divided by 6x squared minus 6x minus 12. All right. Now, this is one that could have worked out like that if, x plus 2 is actually a factor of the denominator. The denominator is factorable, but that's just not going to be useful to us in this situation. Okay, what I'm going to need, I'm looking for an x-intercept, so I'm going to set y equals 0. And you could kind of look at this two ways. You could say either, okay, the only way a fraction can equal 0 is if its numerator is equal to 0, and say, okay, that's going to be when x plus 2 equals 0. Or you could multiply both sides by 6x squared minus 6x plus minus 12, and say 0 times anything is 0. Either way, you're going to end up with 0 equals x plus 2 and x equaling negative 2. And, maybe you plug that in over here. That would give you 6 times 4 is 24 plus 12 minus 12, so that's not a 0 denominator. And I'm going to say my x-intercept is going to be negative 2 and 0. This one's going to be interesting. It's same approach. Going to set the function equal to 0 to find its x-intercept. Either look at it as fraction only equals 0 and numerator equals 0, or multiply both sides by x to the 3 minus 4x. I'm really thinking about multiplying both sides by x to the 3 minus 4x. I think that's going to be better for where y'all are at. 0 equals x squared plus 1. That would be where x squared equals negative 1. And we know that that solution returns us imaginary solutions, but no real solutions. So I'm going to say there's no x-intercept. And then once again, we've got one of these with linear on top and bottom. But actually, that won't be a big deal for us here because we're just going to employ the same tactic, multiply by the denominator to get rid of it. Okay, so I'll have 0 times x minus 5. That's going to be 0 equaling x plus 4. Subtract 4 from both sides. See that x is going to equal negative 4. And then you'll get an x-intercept of 0 and negative 4. Number 4 asks for some y-intercepts, and so we're going to approach that pretty much the same way. We're just going to plug in x equals 0, just like we have when we've found y-intercepts on the graph of any function throughout the year. We've graphed a lot of different types of functions, and on all of them we've been interested in finding the y-intercept, and we've always plugged in x equals 0, so let's just keep with that. All right. F of x equals 10 minus 1 over x plus 2. So I need to plug in x equals 0, so I'll be getting f of 0. The y-coordinate where x equals 0 is going to be 10 minus 1 over 0 plus 2. Okay, so 10 minus a half is 9.5. And I'm going to say my y-intercept is x equals 0 and y is 9.5. For g of x equals negative 9 over x plus 3, I'm thinking the exact same thing. I'm going to plug in x equals 0, so I'll have g of 0, the y-coordinate on the graph of g that corresponds to x equals 0. That'll be negative 9 over 0 plus 3, and negative 9 over positive 3, that's negative 3. So my y-intercept on this graph would be x equals 0, y is negative 3. And the next two will go just the same. We're going to plug in 0 and get 4 plus 5 over 0. Wait a second, that doesn't exist. 5 over 0, that's not a real number. It's undefined, so I'm going to say does not exist. Okay, there's no y-intercept. Okay. And then for g of x over here, I'm going to plug in x equals 0 and get 1 over 0 squared plus 1. So it's just going to end up being 1. So my y-intercept is 0 and 1. Now number 5, now it's going to ask us to sketch some graphs. So that's really kind of what we've been building up towards, but I definitely want to make sure that you're good on all the aspects of the graphs because we're going to do even more sketching of graphs next time in the next lesson. So really, I think that today was mostly about the aspects and the shape of the graph in general, but then we'll kind of mess with that more next time and focus more on the graphs. All right, for this one, I'm going to kind of go by definitely the vertical and horizontal asymptotes, start with that. I might also try to find the x and y intercept and then use all of that information to help me sketch a graph. It might not always be necessary. If you know what a graph's going to look like, just go ahead and sketch it. Right? But for me, I just want to be as explicit as possible in this video so you understand why I'm doing the things that I'm doing. All right, so for the vertical asymptote, that's going to be where I'm dividing by 0. That would be x equaling 0. Okay, the horizontal asymptote, 1 over x, that can't equal 0, but I've got 2 plus 1 over x, so that'll be y not able to equal 2, meaning that y equals 2 is the equation of the asymptote. Okay, the line that I'm getting closer and closer to. All right, an x-intercept, that would be, yeah, that's possible. That would be where 2 plus 1 over x equaled 0, and that would give me 1 over x equals negative 2, so you can flip both sides of an equation, so x over 1 equals 1 over negative 2. So x is negative half, if you like, you can do that. And for a y-intercept, I'm going to plug in x equals 0, and that's not going to work out for me. That's a vertical asymptote. All right, so now I think I'm good to sketch the graph. All right, so my vertical asymptote is x equals 0. My horizontal asymptote is y equals 2. So I'm going to label that and also kind of sketch in that horizontal asymptote. I always try to make my asymptotes like kind of happen in the middle of my sketch and ends up making them look the best. All right, and if y equals 2 is there, the x-axis is where y equals 0. I'll just draw that in here. Okay, and then you could test a point if you wanted. We have an x-intercept. Yeah, x equals negative 1/2. And that might help you because you also know that this is a vertical asymptote. So that can't be crossed. Vertical asymptote can never be crossed. Horizontal asymptote can, though. I've actually seen evidence of that in this homework. And then, otherwise it's a pretty standard 1 over x graph because it's really just been moved up by 2. But I figured I'd show you all the aspects. All right, for B, y equals negative 6 over x. This one I'm going to go pretty quick. The vertical asymptote is x equals 0. The horizontal asymptote is y equals 0. All that's different about this from the graph of 1 over x is that, okay, the negative makes it go upside down. We graphed negative 1 over x. And then we're multiplying by 6, so it'll just be 6 times as tall. Okay, all of the y-coordinates will be 6 times as big as they were otherwise. Okay, so x-intercept, y-intercept, there's going to be none of them. And so I'm going to just kind of quickly draw sketch of this graph. And so, normally 1 over x would be in those two quadrants, so it's negative 1 over x, so it needs to be down here. And maybe I'll, give it a lot of room away from the origin to try to indicate that this has been multiplied by 6 also. Okay, so that's my sketch. It's not great, but that's all we need for this situation. All right, for y equals 1 over x plus 2, we're going to have a vertical asymptote at x equals negative 2, the value that causes division by 0. 0 in the denominator down there, that would be x equals negative 2. The horizontal asymptote, that's going to be y equals 0. X-intercept, there will be none, because 1 over x plus 2 can never equal. Intercept will be, oh no, what's going on here? Not sure how long the screen was black there. I was looking down at the tablet and just writing. I wasn't kind of checking on the computer screen I was recording on. I hope it wasn't black for too long. It looked like my emulating software kind of just quit on me. But either way, I'm over here graphing 1 over x plus 2. I've got a vertical asymptote at x equals negative 2, a horizontal asymptote at y equals 0. No x-intercept because the fraction can't equal 0. Since the numerator of that fraction can't equal 0. And then y-intercept would be the value of y where x equals 0. So it'd be 0 and 1/2 if I plugged in 0, in there for x. All right, so I've got all these ingredients. All right, horizontal asymptote is y equals 0. That's the x-axis. And then the vertical asymptote is x equals -2. So I'm going to just call that -2 and draw in my vertical asymptote. Then I might actually just draw the graph now and come with the other axis last. I don't know why I would do that. Maybe I'll say that's the arrow. There. So it's just kind of a standard 1 over x graph. But then I could go through and put in my y-axis, which I just doesn't really matter where. It's just to the right of x equals -2. And that'll be my y-axis. And then I can label that point x equals 0, y equals 1/2 that I'd already kind of talked about before. All right, for D, this one's got kind of both ingredients. I've got, moving it around a little bit horizontally and vertically. So vertical asymptote will be the x value that causes division by 0. That would be x equals 2. Horizontal asymptote is related to, okay, that fraction's not going to equal 0, so I'm not going to have 0 minus 3, so I'm not going to have a product of -3 from this function. Okay, the x-intercept is where y equals 0, so I might go over here and solve that equation. 0 equals 1 over x minus 2 minus 3. So I'll add 3 to both sides. 3 equals 1 over x minus 2. Good. I'm going to multiply both sides of that equation by x minus 2. So I'd have 3 times x minus 2 equaling 1. Distribute. Add the 6. Divide by 3 and get x is 7/3. Right? And so there we go. Got an x-intercept happening there, a y-intercept. I will just plug in x equals 0, and I would get y equaling 1 over 0 minus 2 minus 3. So I've got 1 -1/2 minus 3 more is y equals -3.5. So x equals 0, y equals -3.5. I'm going to clear out all of that work here so I can just go in and sketch graph. Okay, vertical asymptote at x equals 2. So I'm going to just kind of draw that in. X equals 2. All right, y equals -3 is going to be my horizontal asymptote. So I'm just going to come in through the middle here. Now, if you wanted to start with the x and y axes and make it fit, that you are totally welcome to do that, as this is kind of vanity, making sure my graph looks as nice as possible. All right, this is positive 1 over x minus 2 minus 3. Okay, so it's a regular 1 over x graph. So I always feel like one side of my graph is much better than the other, but that's okay. I'm not trying to make the nicest graph ever here. All right, so if we want a y-axis, that's where y is equal, or where x is equal to 0. So it's got to be to the left of that red line. So I'm going to just come through, I don't know, about like that. Really doesn't matter where, right? Because we're going to intersect that graph somewhere. And then we're going to say, all right, well, that's going to be -3.5. Oh, whoops. I have to do that in green to keep with the same color scheme, -3.5. Right, and then I'm going to need an x-axis as well. And an x-axis is where y equals 0, so that's going to be above the blue line, because that's where y equals -3. Really, it's not going to matter that much. I would definitely like for my y-axis to be a little more parallel to the horizontal asymptote. There we go. Or I guess that was an x-axis, pardon me. I want my axis parallel to the asymptote. All right, there we go. And then that's going to be, okay, if x equals 2, 7/3, that is a little bit bigger than 2. Okay, so my drawing fits with kind of what I solved for algebraically, and so that was 7/3 on the x-axis. And that's going to be my graph. For E, we've got negative 1 over x minus 1 plus 4. So this will be pretty similar to the last one, except for the fact that I've got the negative 1 is going to kind of make it one of those upside down 1 over x graphs. So one of those negative 1 over x graphs. Okay, vertical asymptote, x value that causes division by 0, x equals 1. Horizontal asymptote is going to be y equals 4. You've seen enough of these, you know why it's true. Okay, the x-intercept is where I've got negative 1 over x minus 1 plus 4 equaling 0. Maybe I'll add one of those fractions to both sides. Man, add 1 over x minus 1 to both sides and see that 4 equals 1 over x minus 1. Then I'll multiply both sides by x minus 1. Distribute. Add 4. Wait. Add 4 to 1, get 5, not 4. Divide by 4, and I get 5 fourths, 5 quarters, that's $1.25. I might stick with decimals this time. Nope, 1.25, and y is 0. Right, and then the y-intercept, that's going to be where x equals 0. I guess I'll just go down here and say negative 1 over 0 minus 1 plus 4, that's what y equals, my y-intercept. So I've got positive 1 plus 4 is equal to 5, x is 0, y is 5. Okay, so I think I'll get rid of that writing and start sketching. All right, so vertical asymptote, x equals 1. I'm going to start with the asymptote since I'm on a blank slate. The horizontal asymptote is going to be y equals 4. I'm going to label that, and I kind of wish I had, but let's get that right. Y equals 4. I'll go back and label this as x equals 1. All right, great. And I'm going to just give that a little bit more length there for the quality of the graph. Now it's going to be a negative 1 over x type graph, but otherwise it's just been shifted around. I haven't been like multiplied by anything else. So I'm just going to draw my standard graph here. Whoops, don't love that. Always give it a second shot, but I don't think, especially on the homework, I think it's ever really worth a third shot to make it look better. All right, then I'm going to have one, I think, like that, except maybe since I'm going further down there, I'll show it getting closer and closer. The closer x gets to 1, the farther down the graph's going to go. It's going to continually get closer to the red line, but never actually touch. All right, so that's my graph, as good as I can do. X equals 1 there. Let's just say x equals 0 would be right here. It's my y-axis. And then the x-axis will be way down here. Well below y equals 4, and I'll label my x and y-intercepts. So my y-intercept was 0, 5, and my x-intercept was x equals 1.25 and y equals 0. So that's, yeah, about as good as I can do there, 1.25. All right, and that's the sketch. All right, with G, I've got negative 2 minus 1 over x minus 1. Okay, so yeah, that's gonna be kind of like E, but I wanted to make sure I did one where the minus was on the, like, not in the fraction, so that we saw it looking both ways, because that's kind of equivalent. All right, vertical asymptote, same as always. What causes the denominator to equal 0? That's going to be x equals 1. Horizontal asymptote, as usual, what is y not going to equal, or what is y going to get closer and closer to the bigger x gets? Okay, 1 over x minus 1, that gets really close to 0 as x gets big. It's not equal to 0, but it gets close to 0. And I'll have negative 2 minus something that's getting smaller and smaller, so y equals negative 2 will be my asymptote. X-intercept would be where y equals 0, so 0 would equal negative 2 minus 1 over x minus 1. Add 2 to both sides. Maybe multiply both sides by x minus 1. Distribute. We add a 2 to both sides. Divide by 2, get x equals 1/2. So x equals 1/2 where y equals 0. Then I'm going to find the y-intercept by plugging in x equals 0. So for g, y is going to equal negative 2 minus 1 over 0 minus 1. Okay, so that's equal to negative 2 minus negative 1, so that will be negative 1. Okay, and then I can probably fit this sketch in down here. Yeah, there's nothing really that weird going on. So I'll put in my vertical asymptote. X equaling 1. Horizontal asymptote, where y equals 2. And I'll draw my graph. Okay, this one's going to be a little different. This is going to be a negative 1 over x type graph because of that subtraction there. So it'll kind of occupy these two quadrants. And then I'm going to sketch in my axes after that. Okay, x equals 1, so x equals 0 could be like right there. And that would give me a y-intercept of what's going on here. Oh, this is y equals negative 2. I was like, that's not good. So y equaling negative 2. And yes, definitely believable that that could be negative 1 from the sketch. Hey, that's kind of how you can catch yourself in errors too, is trying to like fit all the pieces together, and if it's inconsistent, obviously you've done something wrong. Okay, so now what's going to happen? I need an x-axis, and that'll be above the line y equals negative 2. Also above the y-intercept, because that's y equals negative 1, so I should probably just go that much farther. I suppose that would be about here. Drawing got a little cramped. Okay, that's all right though, and that's x equaling 0.5. Right? Yeah, and that's a decent sketch. I could do that. Would make it even better though. Label those axes. That would be great. I'm feeling like I forgot to do F, and I'm not sure how I labeled these or what I was doing exactly, and I kind of have erased all my work between each problem, so I'm not sure which one I've done and haven't done. Hey, but I'm pretty certain I've not done the one with 1 over 2x plus 5, because that's like kind of different. So start with the vertical asymptote. What kind of x gives you a denominator of 0? 2x plus 5 equaling 0. 2x equaling negative 5. Divide by 2. Negative 5 halves is negative 2.5. Right, the horizontal asymptote, negative 2 plus a fraction, is not going to be able to equal 0, but we'll approach 0. That's going to be y equals negative 2. Find an x-intercept by setting y equals 0, so 0 equals negative 2 plus 1 over 2x plus 5. All right, I'm going to add 2 to both sides. Maybe multiply both sides by 2. Or by the 2x plus 5, pardon me. Yeah, multiplying both sides by 2x plus 5 to get rid of the denominator, and then I'm going to distribute. Subtract 10, and then get x equals negative 9 divided by 4. All right. That works. Negative 9 quarters would be a little more than $2, so negative 2.25. And then the y-intercept, we're going to plug in x equals 0, and we'll say y equals negative 2 plus 1 over 2 times 0 plus 5. Right, that's negative 2 plus a fifth. A fifth is 0.4, so I'd have negative 1.6. Now I can sketch. I'll sketch in my vertical asymptote. X equals negative 2.5. Sketch in a horizontal asymptote. That's maybe not quite wide enough. It'll be y equals negative 2. And then I will just go to sketching. Okay, this was negative 2 plus 1 over 2x plus 5. So it's going to look like a standard 1 over x graph. It will only be like, say, half as tall because of the 2 down there. We're not too concerned with the specifics there. That's why I didn't give you any grids to graph on. I don't need it to be that accurate. If we need something really that accurate, we can just go to like Desmos or grab our calculator or something. Or just ask Google to graph, and I know that works sometimes. So I have that type of shape of graph there. I'm going to just kind of draw in my y-axis, my x-axis here. That's above y equals -2. Sketch in my my y-axis over here, x equaling 0. To the left. No, that's not going to be right. Yeah, because I'd see my x-intercept or my y-intercept, something about it would be way, way off. Yeah, it would be the y-intercept. Like right there, it wouldn't look right because it's supposed to be -1.6, but it's down there below -2, so it's just not working. That's not going to be a valid y-axis. Yeah, x equals 0 will be to the right of x equals -2.5. So it would be about there, and that will make more sense for the y-intercept to be -1.6. That's more believable on the graph than something that's below -2. That would not be believable. And then, let's see, x-intercept, -2.25, sure. Okay, figure's not drawn to scale, but yeah, that's gonna, it's between x equals 0 and x equals -2.5, so to me it's believable. The last one we've got is y equals 1 over x minus 3 squared. Okay. Vertical asymptote, anything that causes the denominator to equal 0. X equals 3. It's a double root, but I'll just show you what that means on the graph. With the horizontal asymptote, it's going to be y equals 0 because it's a fraction. The numerator is non-zero, so the whole thing can't equal 0. For an x-intercept, I just said the whole thing can't equal 0, so that's not going to be possible. For the y-intercept, that's where I plug in 0. That would be 1 over, say, y equals 1 over 0 minus 3 squared. That's 1/9. Okay, so sketch my graph. Since it's 1 over a number squared, well, that's not going to come back negative. That's not possible, right? We square that number that we're taking 1 over it, and we're going to get a positive number. So we're going to only be seeing positive y values here. And, okay, we said that when, but maybe, maybe I'll clear that out, because we did say there's a vertical asymptote at x equals 3. So I might come through and make that the center of my graph. You don't have to do that by any means. I've already said that. I'm just saying it'll make my graph look a little nicer. And 1 over x squared, I showed y'all what that looked like in the lesson. It looks a lot like, looks a lot like 1 over x, but it's got a little bit more drama to it. And on both sides, it goes up towards the vertical asymptote, outside of being like -1 over x squared. So it approaches 0, pretty aggressively because, the denominator is squared, and we know that squared grows pretty quick. I think I had something else to say about this, but I think I'll put in my y-axis right here, label my y-intercept. Probably also label my horizontal asymptote. Yeah, that was 1/9 right there. My horizontal asymptote was y equals 0. That, and there I've got myself a really good sketch, except for the fact that my y-axis was not labeled, but I doubt I remember to label every axis on all of the graphs that I drew here. Alright, that's going to be all for this video. Thanks for watching. Hope this helped.